So hello everyone again. So come back here. I'm designing the basic circuit. So in the sequence of the even integer. Okay. So this is the very simple like that. Here the mode value is 6. So it will count the sixth state. Okay. So it will go from 0 to 5, and we need the 3 bit, that is the q2. I am telling q2, q1, and the q0. So that is the sixth state total, that is the 00 and 001, 01, 012, and this is the 3, and this is the 4, and this is the 5. Okay. So for msp bit I will I will design. Okay. So for msp bit, so it will be so 4 clock pulse, it will be for it will be 0 for first clock, for first 4 clock pulse. Okay. And for next 2 clock pulse it will be logic 1, because I am designing the a basic circuit. Our motive to design a basic circuit with the 50% duty cycle. Okay, this is the our motive. But how we'll design this thing, a basic circuit with 50% duty cycle? Okay, the C. So firstly there is a input clock pulse is there. Okay, so this is the input clock pulse is there. I am designing a basic circuit with 50% duty cycle. Okay. So while designing the 50% duty cycle with a basic circuit, so firstly this is the clock pulse already given, that is the input frequency. Okay. Now, so according to that, so for first 4 clock pulse it will be 0, and next 2 clock pulse it will be logic 1. See, so for first 4 clock pulse, for first clock pulse it will be like that 0 for first clock pulse, that is sorry, this is the so this is the first clock pulse 1, and so this is the 2, and this is the 3, and this is the 4. Okay. So for first clock it will be 0, and next 2 clock it will be 1, like that. This is the and this is the thing, so it will be logic 1. Okay. This, and this will be 1 again, it will be 0, and 0 like that. So this is the, so this is the f out, sorry, so this is the t out. So here um, so this is the so t out is equal to, so t out is equal to 16. So I design the f out is equal to f in by 6, 6, but it is not of 50% duty cycle. See, because of that, for first clock, for first 4 clock it will be 0, and only for 2 clock pulse it will be logic 1. So if I calculate the percentage duty cycle, then in that case, that is the total on value is only 2, and off value is 4. So 4 plus 6, 4 plus 2, sorry, 4 plus 2, only on value is 2, and the off value is 4. So 4 plus t on plus t off, so 2 by 6. Okay, this is the 1 by 3. So this is the 33% duty cycle. But our question is design the f by 2 circuit with 50% duty cycle. Okay, but here I design the sorry, the our question is design the f by 6 circuit with 50% duty cycle, but here I design the f by 6 circuit with the 33% duty cycle. So how I will change the mode value? So this is the our purpose, how I will change. So so here I am telling one thing, you should remember that thing. The positive edge trigger d flip flop, positive edge so sorry, the positive edge trigger d flip flop provide the 1 clock cycle delay. You should remember and write down. So this thing I will erase. The D flip flop, positive edge trigger D flip flop, positive edge, so positive edge trigger D flip flop always provide the 1 clock cycle delay. Okay, 1 clock cycle delay. You should remember this thing. Okay, and the negative edge trigger D flip flop, negative edge trigger D flip flop, negative edge trigger D flip flop provide the half clock cycle delay. Okay, half clock cycle delay, half clock cycle delay. These two thing you should you should remember always. Okay, if you want to change the mode value, if you want to change, sorry, the duty cycle, you should remember that thing. The positive edge trigger D flip flop provide the 1 clock cycle delay, and the negative edge trigger D flip flop provide the half clock cycle delay. This thing, so remember this thing. Okay, I am erasing. Okay, so here the our question is design the F/6 circuit with 50% duty cycle, but here I design the F/6 circuit with 33% duty cycle. I design this thing, but how I will change? No, we'll add the extra, the D flip flop, positive edge trigger D flip flop, because the circuit is look like that. This is the so this is the mode 6, this is the mode 6 value, and this is the input frequency is there. Okay, this is the input frequency, and F out I design the F in divided by 6 with 33% duty cycle, 2 by 6 yeah. So this thing I designed. So how we can change this thing in the 50% duty cycle? So this is the thing. Okay, come back here in the graph. So in this thing, I need to design the with the 50% duty cycle. Okay, so for 50% duty cycle, just I will add one extra D flip flop at the output of the effort. At the output of the effort, or it will provide the 1 clock cycle delay. It will provide the 1 clock cycle delay, like that. So here I can see this is the thing. So so for referencing I am telling this name is the q1, q1, this graph, q1. Yeah, you can tell anything like that. Just for referencing I am telling this thing is, so this I'm naming, this is the that is the s1. This thing I am telling this graph s1 now. So if I add the one deep positive HT or deep flip flop, it provides the 1 clock cycle delay, like that. So this is the thing. This is and this is the 1 clock cycle delay. So it will provide the 1 clock cycle delay, and it will go like that. Now, if we, and this thing I am telling like that. This is the S2 I am naming. I can I can make any name. Okay, and just I will add one OR gate. By the adding of the this OR gate, so by the adding of the OR gate, it will be 0 here. Up to that, it will be 0. Then logic 1, logic 1, logic 1, logic 1, and this is the 0. Okay. Here the graph is sorted. But so this is design. So this thing is the total implemented with F by 6 circuit with 50% duty cycle. How we are telling? So for first, so on time and off time, it should be on time and off time is same. This is the total off time, and this is the total off time, like that. If we go further, here I am here I am considering this is the 1 clock. So this is the one time period. After that it repeat, no. So this is the one. So here on time and off time is same. Okay. So the F6. So here the total is the 3 by 6 into 100%. So if we so 3 times, sorry, yeah, the 3 divided by 6, that is the 1 by 2. This is the 50% duty cycle with F by 6 circuit. So how we'll make this circuit? And this is the mode, so mode 6 counter. Okay, this is the mode 6 counter, and this is the input frequency. This is the input frequency, and this is the effort. So here effort in the naming, so what I tell, so what I here I told, effort is equal to effort, just I consider this is the S1. Okay, so effort is S1, just I consider this is the S1. Yeah, if you don't consider, it's okay. Okay, no problem. Here I will attach the one, the positive edge trigger D flip flop. The positive edge trigger D flip flop. Positive edge trigger D flip flop will provide the 1 clock cycle delay. That is the D flip flop, and this is the Q and Q bar. Okay, or here that is the, it provide the 1 clock cycles delay. Now here at the output I will connect, that is the OR gate. So this thing and this thing. Okay, this is the one OR gate. So this is the complete circuit of a by 6 circuit with 50% duty cycle. Okay, so this is the thing I need to design the f by 6 circuit with. So what I told this name, like this is the S1 I told, or this is the S2. After shifting I told this is the S2. So after OR gate, this is the f by 6 circuit with the 50% so duty cycle. Okay, means 50% duty cycle means on time and off time should be same. On time and off time should be same. So for this graph, on time and off time is same. Okay, so here we can see this is the on time, this is the on time, and of time is same. If we go further, if we draw the further clock pulse, and if I consider the time period like that, it will be same on time and off time. Here you can also see. Okay, so this is the complete thing, a basis circuit with 50% duty cycle. Okay, so thank you everyone. So here I design a basics with 50%. Thank you.